Mm, Ladies and gentlemen, I'm Professor Yonghui from Hohai University. It's my pleasure to be here today, the 19th of July 2023, to discuss the very short-term probabilistic prediction of PV based on the multiploidal error distribution. Today's presentation can divide into the four parts. The first one is the background and the problem. The second one is the PV deterministic forecasting, and then the probabilistic forecasting, and the last one is the summary and the prospects. Now, in the first, we introduce the background and the problem. The first part is the background. Why we need to do the PV forecasting and why is it so important? As the fossil energy sources continue to be depleted, environmental pollution is becoming increasingly serious. PV has received widespread attention. Although the COVID-19 has left a certain impact global, the new installed capacity of the PV worldwide is still at a high record, which is still growing, especially in recent years. The cost of PV generation has gradually decreased, and also the the, the land PV has been re- repeatedly repeatedly development and applied. And then I will introduce while the large number of PV connect to the power system, it can cause some problems, such as how do we connect more PV to the power systems, and how do we maintain a balance between the PV and the generation. Oh, PV is a node and the generation. And how do we plan to build more PV farms? And how do we get information about PV faster? Therefore, we need very short-term PV forecasting. We need very short-term PV forecasting within 4 hours. The 4 hours is by definition as a very short term. It improves, and the benefits of the accurate PV forecasting are three aspects. The first one is it improves the energy efficiency by helping us optimize the energy consumption and reducing waste. And it helps mitigate energy costs by production, energy supply, and demand, leading to better cost management. It reduced the carbon footprint by enabling users to optimize the systems for efficiency. Our approach to PV deterministic forecasting involves using data-driven models and decomposition models, such as EEMD and LSTM. For the decomposition, we commonly use the EMD and it improved models. For forecasting models, we commonly use the recurrent neural networks, simply called RNN. In particular, LSTM, due to the LSTM has been proven to achieve the good forecasting performance in time series. So, in this model, after we applied the LSTM as the main forecasting model after the EEMD. The EMD contains a large amount of white noise after grading. Therefore, those white noise in both positive and negative directions was added to the original screens before the EMD. This removes the interference of the white noise after decomposition. The left picture is showing the EMD results, and the right picture is showing the very short-term PV combined forecasting. And we use the LSTM forecasting model to forecasting every decomposition, such as IMF1 to IMF10, and the last one, RES. And also, after the deterministic forecasting, we introduce the probabilistic forecasting. Why we need the probabilistic forecasting? Since the error in deterministic forecasting are inevitable, and the PV output is the randomness, can we describe the randomness of the PV? Sure, of course, we can to describe the two boundaries, such as the upper boundary and the lower boundary. The boundary contains the actual output, such as the upper boundary. It can use to power market binding by generators and coordinate dispatch discussions, and the lower boundary can use to quantitative risk assessment, spread capacity optimization. To describe the randomness of PV, we conduct error analysis for the multiplied probabilistic forecasting. This involves examining error distribution of the different time prices and the segment point paths of the error space. In the left picture showing the its distribution over different time prices, it can divide to the high, the medium, and the low. And we propose to divide the different prediction error value to the different error set. And the right picture is showing the segment point price of the error set. And then we imported a technique such as kernel regression for this purpose, because we need the probabilistic forecasting, so we can to calculate the error distribution and combine the error distributions and the deterministic forecasting results. We can calculate the probabilistic forecasting results. In the first, we we to get the deterministic forecasting results by the EMD and LSTM and build the error sheets, and then we to get the NW kernel regression fitting the error distribution functions, and then evaluate the segment point. If the accuracy satisfies my purpose, I will output the probabilistic forecasting result. If the accuracy not satisfied my purpose, we will adjust the parameters. We have conducted a case study to demonstrate the application of the error distributions and our EMD LSTM BP model for the typical data prediction errors. The BP's model is a simpler construction, so we used the BP to forecast in the simple IMF, and then we combine the LSTM and the BP forecasting results to the last results. And this picture shows the probabilistic forecasting of the different error distribution at the 95% confidence. We can show in this point. In this point, our proposed model can contain the real output, but the uniform error distribution cannot contain. So our proposed multiplied error distribution is get a good performance than the traditional error distribution, especially in the score. The score is the Winker score is the most important value in the probabilistic forecasting. In summary, we have explored deterministic and probabilistic forecasting step by step. In the first, we establish deterministic forecasting, and then analyze, and then get the probabilistic forecasting. But many people to get the probabilistic forecasting use the QR modeling. We use the third step we use this third step to get the probabilistic forecasting. It have many good aspects, such as if you can get the deterministic forecasting, you can get by the EMD and LSTM model, and then if you can get the probabilistic forecasting, you can get it based on the deterministic forecasting. And in the future, we can focus on improving the forecasting models with the physical theory machines of PV, because the data-driven model it's a black box, and we can build in some similar parametric probabilistic forecasting models, and to learn how to deal with the large clusters of PV. I want to thank you for your time and attention today. Thanks.